To define the hyperbola, it is the set of all points xy whose difference of distances to two foci is constant. So we'd alter the definition of the ellipse just slightly. Instead of summing distances, we now take the difference of distances. Let's see that in a drawing. That'd be helpful. So if you remember the hyperbola, it's these two arcs with this gap in between. It's real easy to think that these are two parabolas. They're actually not. They seem like it at first, for sure. But these are not two parabolas, but they do have a similar feel to them, most definitely. So the idea is if we think of any point on either of these two curves. So if we take the distance from the first focus and the distance to the second focus and subtract, then that difference is always going to be the same no matter where we pick. So if we were to pick something in here closer, then those distances will always be constant, even across the middle. So if we went to maybe vertex 2 and then to that all those differences would always be the same no matter where we look. Again, you notice that now the vertices V1 and V2 are inside the two foci. So it's like, what we did, we literally took the vertices in the ellipse and we started pushing them in. And as we started pushing them in toward the foci, right, what happened? So that altered the shape of the ellipse, and then when we pushed them through to the other side, it like rips the ellipse inside out, and it's kind of got this split going on. When you really start to study the conic sections, and you kind of get to higher levels of the way you're thinking of them, turns out they're all actually the same. We can describe all three types of conic sections in the same way. So there's kind of like another level of like you kind of dig in deeper and it turns out they're all actually one. Hyperbolas, by the way, are very useful when analyzing imaginary numbers, which is really interesting. The ellipse, it's like when you start pushing those vertices in and they pass through, it's like you've crossed into the imaginary numbers. So the ellipse is like, say, like the real numbers, and then you just kind of like go through this phase and into this other dimension when you push your vertices on the other side of the focus. It's okay. I don't know if you guys are really into that sort of thing. Like, obviously I am. But I'd say when you've studied something for several years and then you like get that kind of revelation, like, whoa, that's really powerful. It's really fun. All right. Anyway, if you'd like to talk more about the connection to imaginary numbers, come to a Zoom meeting. Okay, so let's get a nice drawing here. Something like that. Okay. You may remember, there's a lot going on in this drawing. You may remember from pre-calc some of these things. I wouldn't be surprised if you do. So there's the center right there between the two vertices. There's our two foci on either side. So we've got some familiar designations for distances. So from the center to the vertex, we call it A. From the center to the focus, we call that distance C. Okay, but now, of course, C is bigger than A is. Where does B come in? And what's up with these asymptotes? Okay, it's all tied together. So you may recall from pre-calc, when you go to graph a hyperbola, you have to create this rectangle, like this box. So if you know the value of A, that's how far you go out horizontally here. If you know the B, that's how far you go vertically. So knowing the length of A and the length of B, you can make this rectangle with the center right at the middle. Then you draw these two lines connecting the center to the corners of that rectangle. Okay, the center to the corners. And we call those the asymptotes. So we can see how A and B, are connected with the asymptotes. C is going to be connected to the values of A and B in a similar way as the ellipse with the Pythagorean theorem. It's not exactly the same, but it's very similar. All right. Also, when you go to actually draw the hyperbola, the arms is what we call them. The arms tend toward those asymptotes. Why we call them asymptotes? Okay. So the standard form. So it